So when you are trying to find out for the element, what I told you is focus on the protons only. So in number 2, the protons is 19 and the protons is equal to atomic number 19 also. So all you need to do is look at the periodic table and look for element 19. What element do you see on the periodic table as element 19? Anybody who can tell me? It is?
Potassium.
Potassium. Very good. So element 19 is potassium K. And that is for number 2. Remember, we're still focusing on the protons only to get the name and the symbol. In number 3, there's no number of protons, so what you need to do is you count the dots for the protons. For my black and white printout, my dots, my bold dots are my protons. So I count it as 5. And I count also the electrons to be 1, 2, 3, 4, 5. So I put 5 there. And the neutrons are the gray dots. And I also count it as 5. So it's just merely counting. So I can supply the numbers here. And then because I want to know the name and the symbol, I focused on looking at the number of protons, which is 5. So I go to the periodic table. What element has an atomic number of 5?
Boron.
Boron. So that will be boron right there, and that is capital letter B. For item number 4, your protons is 13 here. So similarly, go to the periodic table and look for element 13. What is the element that has an atomic number of 13?
Aluminum.
Aluminum. So write it down. Aluminum or aluminium. That's okay. And the symbol is capital A, small l. So that is your aluminum. L is written as a vertical L because it should be a small letter. And then for number 5, all we need to do is count how many protons we have. So that's the bold ones. So I count it, it's 8. And then I just count the electrons as well. So that's also 8. And then we count the gray dots with the protons, and that's also 8. And so that's going to be 8, 8, 8. If your drawing is not so similar to mine, because I edited this, just follow my numbering here, okay? So 8, 8, and 8. So if you're writing this down on your notebook, copy how the electrons are distributed surrounding the nucleus of the atom. So there should be 8 electrons so that the protons and the electrons will be equal in the neutral atom. So if our protons is 8, how or what element are we talking about with an atomic number of 8? What is it?
Oxygen.
Oxygen. So we're now going to write oxygen. Oxygen, and that's capital letter O. And so now we're finished with the names and the symbols of the elements. So that's always the start. Find out first what's your element and what's the symbol of that element with the use of the periodic table. And your gateway to do that is the protons. So just look at your positive, and that's how you're going to find for the element. So now we're going to draw the picture of every atom we're given with. I want you to listen carefully that when we draw the picture of the atom, there is a sort of organization and structure that we need to follow. We just don't follow randomly wherever we want to place our subatomic particles. There's no way that you can just choose wherever you want to place them. There is a structure. So let us start first by drawing our nucleus. Let's draw our nucleus, the one in the middle. Our nucleus, you know that it contains neutrons and protons. So when we're drawing these two, can you please use the different colors of the pen to make sure that you distinguish between them, okay? As for me, I will use a black pen for my protons, and it says 6. So I have to draw 6 dots for my protons. So that's 6. 6 dots. So protons is 6. I check that. I'm done. The next particle I'm going to draw is the neutron, which also has 6. So I'm going to use a different shade, which is I'm going to use a pencil to make a lighter dot. So I should have 6 dots together with the protons. 1, 2, 3, 4, 5, and then 6. And that is my neutrons, and I'm done with my nucleus. Okay, so I'm drawing the nucleus first. How about we draw the nucleus of the second atom? Let's draw the nucleus. Let's start with protons with 19. So you draw 19 dots. So let's draw first all the nuclei of our atoms, okay? To make sure it's organized. Okay, now I have 19. 19 protons for number 2. And then I will draw 20 neutrons together with the protons. So while I'm doing this, you also do your own drawing and your own counting. Okay, now I have drawn 20 dots for my neutrons. And so my nucleus is already ready for my second atom. And the last drawing that I need to do is for aluminum. Aluminum has 13 protons. So let's have 13. Okay, 13. So my protons is done. Now I'm going to draw my 14 neutrons. So 14 neutrons. Okay, so now I'm done with my 14 neutrons. So all my 3 nucleus are, we're going to draw our electrons. That's the very last particle we're going to draw. The electrons are very tricky when we draw them outside the nucleus of the atom. Why is it tricky? It's because the distribution of the electrons should follow a certain rule. And the rules are the following, which I will write down on the paper, okay? The electrons are occupying the electron cloud. Your electron cloud has energy level. And the energy levels are represented by this circular line that you put. So the first circular line that you put outside the nucleus is your first energy level. So you always start with the first energy level. Draw one circle there. However, there is a rule. In the first energy level, only a maximum of 2 electrons should be there. So let me put max. That's the maximum electrons that you can put there. So in your boron, for example, if you notice in your first circle, you only see 2 electrons because that's the rule for the number of electrons that will occupy the first energy level. So 2 electrons right there. If you look at oxygen also here, look at the first orbit, the first energy level, you also see 2 electrons because that is the rule for the first energy level. If 2 electrons is not enough because you have more than 2, then you have to proceed to the second energy level. In the second energy level, it means you need to draw another circle after the first circle. So this is the second energy level of boron. The next question is, what's the max I can put in my second energy level? The max is 8 electrons. That's the maximum electrons that I can put. If you look at boron, in the second line or second energy level, you only see 3. Why is it only 3, not 8? Remember, 8 is maximum, so you can have less than 8. Why is it only 3? Because boron only has 5 electrons, and the 2 are already in the first energy level. So that means all boron needs is 3 more electrons in the second energy level. So that 2 plus a 3 will give you 5 electrons. For oxygen, if you look at oxygen here, oxygen has 8 electrons. 8. So the first energy level has already 2. So in the second energy level, oxygen needs 6 more. Just 6 more to have 8. So that's why if you look at the second energy level, if you count it, it's 1, 2, 3, 4, 5, 6. So there are 6 plus 2, that's a total of 8 electrons. So the second orbit doesn't reach the max of 8, just 6. However, if you need more than this, for the second energy level, like 8 is the max, but you need more, then no problem. Just add a third energy level. And the third energy level will have a bigger capacity of 18 electrons maximum. And that's where we will stop for now, okay? The energy levels can go over the third, but for now, we will just focus up to the third energy level. So now we're going to draw carbon, okay? We're going to draw carbon. Carbon has 6 electrons. So always begin with the first energy level. So first energy level is 1 circle. And first energy level, 2 electrons. So I only put 2 electrons. So E negative, E negative. So 2 electrons on the orbit. Okay, first energy level. But I need 6. I only have 2. So that means I have to proceed to the second energy level. I draw another circle for the second energy level. And how many more do I need to add to get a 6? I already have 2. So that means I will add how many? 4 more electrons. So 4 more, 4 plus 2, I have 6 all in all. So I have drawn the 6 electrons of carbon properly. If you look at the second energy level, 8 is the max, but I only draw 4 because I have to stick with 6. So I have to make sure that I have 6 all in all in this drawing. Any questions about carbon? Now let's go to potassium if there's no question. Potassium is challenging. There are 19. That's a lot of electrons. But don't worry. All we need to do is follow our energy level and the maximum. Okay? So we always begin with the first energy level. So first energy level, 1 circle. And the max is 2 electrons. So I put 2 electrons there. So I already have 2. 19 minus 2, I have 17 more to draw. So after the first energy level, I go to the second energy level. So I draw another orbit here for the second energy level. And the max is 8. So I have to max this out because I need 19. So I have to max out my 8. So let me draw all the 8 there. 1, 2, 3, 4, 5, 6, 7, 8. So I draw 8 plus 2 here. That's a total of 10. Still 10. But I need 19. But I've maxed out my second energy level. So what does that mean? I have to go to a third energy level. So that means my atom is really big. My potassium atom is really big. So I'm going to draw my third orbit there. And because I already have 10, the max is 18. I don't think I can reach the max because I only need 19. I have already 2 plus 8, I have 10. To get a 19, I need to add 9 more. So the 9 more will be distributed in these 3 third orbit. So that's 3, 4, 5, 6, 7, 8, and then 9. So I now have 9, just 9 on the third energy level, not 18, just 9 because I need to satisfy the total electrons, which is 19. Any questions so far with potassium's drawing? Okay, so that ends my example. This time, it's going to be your task to draw aluminum on your work, and once you're done, submit your work.